Welcome to today's webinar. I'm Steve Whelan from Hariba and I'll be your chairman. The focus of today's webinar is the recently announced Euro6e. To introduce and brief you on this new information, we have one of the UK's leading authorities on vehicle emission regulations, Mr. Simon Williams of Mahle Powertrain, who I'll introduce to you shortly. Firstly, let me explain today's webinar. The webinar will be split evenly between a presentation from Simon and a Q&A session, roughly 30 minutes for each session. There is a facility to ask questions via the chat window. Please feel free to ask questions anytime and any type of question. My role as chairman is to collate these questions and pass them to Simon following his presentations. Unfortunately, you will not be able to ask questions verbally. I'm not expecting a shortage of questions considering the controversial nature of the subject matter, so I'll try to get through as many questions and question groups as possible in the Q&A with Simon. If we cannot answer your questions due to time constraints, Simon is happy for you to contact him directly via the details that will be given during the webinar. During the presentation, there will also be a poll with questions for you, the audience, to answer. These questions will gauge your views on certain aspects of Euro6e. I'm now going to run through and publish these poll questions. You can answer this poll during Simon's presentation, and he will discuss the outcome of this poll at the end of his presentation before the main Q&A. Okay, so question one, what is your opinion on the implementation timing of light-duty vehicle Euro6e? Too early, too late, just right? Question two, what is your opinion on the pollutant and limits, RDE limits of light-duty vehicle Euro6e? Too lenient, too aggressive, just right? Question three, what is your opinion on the implementation timing of heavy-duty vehicle Euro6e? Too early, too late, or just right? And question four, what is your opinion on the pollutant and RDE limits for heavy-duty vehicle Euro6e? Too lenient, too aggressive, just right? And then finally, question five, do you think Euro6e will reduce the number of light-duty vehicle ICE applications available in the EU market? And that's a yes or a no. So I will publish those questions now. And you should see them come up. Bear with me. Okay, hopefully they all are visible now to you. So let me start this off now with a brief introduction of our speaker, Mr. Simon Williams, who works in the Performance and Calibration and Controls Group at Mahle Powertrain Limited in the UK. Simon studied at Loughborough University and completed a master's degree in automotive engineering. He joined Mahle Powertrain in 2006 in the calibration department, where he specialised in onboard diagnostics, OBD, and emissions calibration. In recent years, he has been responsible for implementing RDE testing capability, enabling Mahle Powertrain to become the first VCA certified RDE testing facility in the UK. Currently, Simon is responsible for forecasting global automotive regulations for Mahle Powertrain and clients of Mahle Powertrain. Simon is well qualified to brief you all on the delights of Euro6e. So I'll finish my introduction there and hand over to Simon. So over to you, Simon. Thank you.
No, thank you, Steve, for that introduction. Yeah. Good afternoon, everyone. Thank you for joining us today to review the roadmap to European emissions legislation. So we're going to talk today about Euro6e and also Euro6e as well. So just to reiterate what Steve mentioned, so I'm based in Northampton, head office of Mahle Powertrain in the UK. I've got my details here on the slide, so if there are any more questions after the presentation or any of the questions don't get answered, please feel free to get in contact and I'll answer what I can. So For those of you who don't know who we are at Mahle Powertrain, I've got a small little overview of who we are, what we do, and our background as well. So basically, we're an independent engineering consultancy. We've got over 350 employees worldwide, with a large global footprint as well. So we've got offices in Great Britain, Germany, USA, and China as well. And 5 of those are pure R&D locations as well. So we've got over 70 global customers, and including all the major sort of vehicle OEMs. I think the key point that for Mahle Powertrain, what we try and deliver is engineering sustained high performance. So over the last 60 years, Mahle Powertrain has been supporting clients to solve complex engineering challenges and adapting to the changing demands of the industry. And one of those key demands now in the short to medium term, as you're all probably aware, is why you're here, is Euro 7. And really looking forward to the longer term, Mahle Powertrain see we've got a dual strategy really focused on delivering sustained high performance for EV vehicles and systems, but then also sort of unlocking the full potential of internal combustion engines as well, with new technologies, new fuels, new capabilities that we see coming into play in the short to medium term. So really this then drives our sort of dual strategy. So really driving our expertise in electrification, which is built on the rich heritage of our experience in ICE combustion as well. So really trying to drive those 2 key powertrain solutions forward in the next years. So moving through now to the EU regulation outlook, what I wanted to do was to start briefly discuss what we see with Euro6e and then move on to going through Euro 7 in a lot more detail. So what we see with Euro6e, it's going to be introduced in 3 stages. So we're going to have a Euro6EA, EB, and EC. The EA content is going to include some small changes for WLTC and RDE UNECE updates. We're going to see updates on RDE from the conformity factor for NOx and PN. And then EB will deliver additional updates on top. So that includes increasing the upper temperature threshold for RDE for the normal and extended conditions. One of the key changes is going to be on the CO2 requirements of the PHEV utility factor. So the initial step is going to apply in Euro6e EB. And then for OBD, we're going to see an auxiliary emission strategy flag that needs to be reported by the vehicle whenever the vehicle is running in an auxiliary emission strategy mode, which then can be interpreted during a type approval test or a market surveillance test, for example, which then links to your AES documentation as well. So that's a significant change from where we are at the moment. And then Euro 6 EC comes along, and that brings the final PHEV CO2 utility factor update as well. So then with the timing, this is quite tight. So the proposal was voted for Euro 6e in August 22, and then the requirement is for the first new type approval is going to be in September 2023, and then all types for Euro 6 EA from September 2024, and then a 2-year cadence from EA until we reach the final EC implementation in 2028. I think the really interesting point that was raised when Euro 7 announcement was released in the 10th of November is that actually all of the points for Euro 6E are going to be superseded by Euro 7 starting from 2025. So moving on to the Euro 7. So after 20 months after the final Clove meeting for the legislation discussions, the proposal for Euro 7 was released on the 10th of November this year. There was quite a wide range of reaction across all interested parties. And really, if you look at it, all interested parties appear to be equally disappointed in the regulation, dependent on their viewpoint. But really, what I wanted to talk through today is actually what does Euro 7 really mean for the automotive industry moving forward. So again, one of the interesting points of why I wanted to do the survey today was to get the input of the audience today and see what the opinions are from the audience and where Euro 7 really sits and what the opinions are of Euro 7 for the diverse audience that we've got here today. So looking at the legislative timeline, so we've got the proposal published by the European Commission on the 10th of November, and now that proposal is in the EU legislative procedure, where changes can be made to it from the EU Parliament and Council. But then the actual final delegated text, we don't believe will be ready until Q1 2024. I think there's a really interesting point that was made in the most recent AGVES meeting at the start of December this year, is actually the European Commission don't see any change content on the proposed EU7 proposal. AGVES is only there to define the delegating act, so any future AGVES meetings are only there to discuss the technical content of the delegating acts. So looking at the timeline, if you then consider when the end of the Euro 7 legislative proposal is to be in Q1 24, that gives a very short period of time to go from the final fixed regulation to when the light-duty vehicle implementation is needed to be on July 2025, and then for the heavy-duty implementation in July 27. And then there's a derogation for small volume OEMs for Euro 7 happening in, that's going to be a requirement from July 2030. So really, that could, as I said, really short period of time from when we've got the fixed regulation through to when the regulation needs to be implemented. So that's 18 months for light duty, 42 months for heavy duty. So a very, very short period of time for OEMs and tier ones and suppliers to really deliver on the Euro 7. So with Euro 7, one of the points that was included within the proposal document is around the option for Euro 7 to have different type designations for vehicles within the Euro 7 requirements. So the first one is the Euro 7 plus requirements. So you're going to have the option for ICEs and no-off vehicle charging hybrid vehicles certified as Euro 7 plus if they declare 20% lower gaseous emissions and one order of magnitude lower PN emissions than the standard Euro 7 requirements. And then if you've got a PHEV application, if you declare the gaseous and PN limits plus then a 10% higher battery durability than the Euro 7 requirement, that could be also applied as a Euro 7 plus vehicle. And then for battery electric vehicles, again, if you certify to a 10% higher than the Euro 7 requirement, that can be a Euro 7 certified vehicle, 7 plus certified vehicle as well. And then with Euro 7A, this is for vehicles equipped with adaptive control features. And within the most recent AGVES meeting, the European Commission proposed that this would include predictive cruise control and event horizon systems. We could then have, if they're implemented on vehicle and type approved with those systems in place, then they could be defined as a Euro 7A vehicle. And then a Euro 7G is for ICE applications with geofencing technology. So this is mainly around PHEV applications where you have your EV range, and then if you can, these geofencing technologies will just prevent or enable the vehicle only to use EV operation in a city or specific urban environments. But then the vehicle, if the vehicle runs out of charge, you won't be able to turn on the ICE engine to be able to move the vehicle. But then if you have that geofencing technology, you could certify your vehicle as a Euro 7G application. And as you can see on the plot, these designations can be combined into a number of different EU7 designations, so Euro 7AG, A+, for example. But I think the one interesting point to note is actually there's no benefit that's been defined on why an OEM would certify their applications to these levels. And that's something that we believe will come through the delegating act of Euro 7 that we'll see over the next 6 to 12 months. Another interesting point that was added for Euro 7 is the requirement for vehicle passports. So this is data and documentation on the vehicle that will be accessible through the vehicle multimedia interface for the user of the vehicles as well. So this will contain a significant amount of information on the vehicle and about the vehicle, but also about the current durability status of the vehicle. So when you look at battery durability as well, and sort of EV range, fuel consumption, that kind of thing. And then there's also the other related values, which has been written into the text, and we believe this will be a requirement for some status on the vehicle onboard monitoring for the emissions level of the vehicle versus the certification requirements as well. That's what we see. That's going to be a requirement for the vehicle passports and to be read by the user of the vehicle. And the other aspect of this passport, it will be able to be communicated over the air as well. So this vehicle passport is one of the key pillars of the digital ambition that the European Commission has for the Euro 7 regulation. So then if we move over to the proposals for the Euro 7 for light duty applications. So I've got the table here showing where we will be with Euro 6e, and then what that step is then to where we are with Euro 7. So the first column for Euro 7 shows the emissions limits per kilometre, and then the second green column then shows the emissions limit per trip or per budget trip. So I'll give a bit more detail on that in the next slide. But the interesting point about these emissions limits, as they deviated away from the proposals from the CLOVE consortium, and the reductions were less than the industry expected. But they weren't carried directly over from where we are with Euro 6e, because it was taken for the lowest Euro 6 value. So for example, for NOx, the gasoline value of 60 was taken, and for CO, for example, the diesel value of 500 milligrams per kilometre was taken. Then also when you add the EU7 conformity factor has been reduced as well, or removed. So this then reduces the NOx limit by at least 10% and the PN emissions by 34% as well, compared to where we are with Euro 6. So it's not a direct carryover from where we are with Euro 6e. So then the emissions budget. This has really been implemented to enable a shorter RDE cycle distance. So you have your budget. So this is an example here for your NOx emissions. So for your emissions budget, for the first 10 kilometers of any RDE drive, your emissions budget is going to be 600 milligrams of NOx. And as you go past that 10 kilometer distance, say for example, up to 25 kilometers, you'll then increase your budget by the 60 milligrams per kilometer. So for example, for a 25 kilometer trip, you'll end up with an emissions budget of 1500 milligrams of NOx. The other key point to note is around Euro 7 is that it's primarily an on-road legislation. So all emission species are going to be tested over RDE where possible. So that means that the default Euro 7 testing method is an on-road RDE test. Where the emissions can't be measured on road, this is where it will be brought back into a lab, for example, but these will then be tested over an RDE cycle. The WLTC cycle will be there still, and we'll still test the WLTC cycles, but this will be mainly for CO2 measurements for fleet average compliance. Then another point where the Euro 7 has strengthened is in the market surveillance as well. So they're really pushing to increase the market surveillance. This is through the use of the onboard monitoring systems that will be installed on the vehicles, more of which I'll discuss later, and then also the remote sensing devices, but then also performing supplementary RDE and lab testing by member states or the European Commission, and also third parties as well can provide data into the market surveillance that the European Commission will review as part of the Euro 7 requirements. So the next slide here shows the RDE proposal. So this is pretty equivalent to what was proposed in the CLOVE report, apart from two key changes in our view, is that the extended driving divider has been reduced to 1.6 rather than what was proposed in CLOVE, and this has been taken across from the Euro 6D requirements. And there's no allowance for any vehicle abuse conditions, for example, within the regulation, which was a bit of a surprise for some of the industry. I think one really interesting point that came out of the most recent CLOVE meeting earlier this month is that it was verbally suggested by the European Commission that an RDE test is void if more than one extended condition happens at any one time. So this is something that isn't written down in the current regulation, but it's something to be very aware of moving forward in designing Euro 7 test conditions and Euro 7 specifications for hardware after treatment systems, for example. But this is still going to be discussed over the next number of AGVES meetings, and will be something that will likely be included in the acts to follow, the delegating acts for Euro 7. But really, overall, with these changes to the RDE boundary conditions, they are significant, and then they will need updates to the powertrains to be able to deliver and meet the Euro 7 requirements. So what I wanted to do was just talk through quickly some of the technology requirements where we see, and just bring out two key changes to the RDE or the Euro 7 requirements over Euro 6e, and discuss those and show what they mean for OEMs. So if we look at, for example, component protection operation, I've got here a vehicle that we've tested here at Mahle Powertrain, and then overlaid the data with the whole area map of that particular engine as well. So you can see for a Euro 6D type RDE test, which is a worst case sign-off test that we use to validate our emissions calibration here at Mahle Powertrain. We've run the vehicle over that cycle, and then we've run the same vehicle over a Euro 7 worst case test that we've developed here at Mahle Powertrain as well. So you can really see the difference that our RDE for Euro 7 has, for the increasing boundary condition has, on where you can actually operate your engine over an RDE cycle as well. So when you overlay this with the component protection boundaries, we then see some quite significant implications for CO emissions, THC emissions, and ammonia emissions, for example, when you're running in these component protection boundary conditions. So really has significant implications on your engine design and where potentially you optimize your powertrain to run. So, just for some example, what you can do to rectify this or investigate what you can do. If it's a PHEV application, potential adjusting the balance of your ICE to EV component, reducing the ICE performance levels, then mitigate the requirement for component protection, for example. The other opportunities are for ICE or MHEV applications, is looking at pure hardware optimization, so improving your knock mitigation or improving your temperature management, or more hardware that's more robust to higher temperatures as well, to try and improve that. And those are pieces of work that we're doing at the moment for our clients. The other aspect is around NH3 emissions as well, and the control of ammonia emissions as well. So there's two real key parts to this, is about what you can do with your combustion and your engine out emissions, and then what you can do with your after treatment hardware as well. So one of the key impacts of ammonia emissions is how well you control your lambda out of your engine. So this is for light duty applications, I should say, for gasoline. So you need to optimize your lambda control, understand that, but then also consider the after treatment specification and layout as well. So the design of your three-way catalyst in a light duty gasoline application can and will have implications on your ammonia emissions. So there's levers that can be pulled to improve your ammonia emissions or reduce your ammonia emissions with your catalyst. So increasing the catalyst volume and changing your precious metal loading ratios as well will have impacts on your ammonia emissions, which then sort of drives the fact that possibly there isn't going to be a requirement for ammonia slip catalysts for all Euro 7 gasoline applications. So moving on to a bit more detail into the technology requirements, looking at the after treatment systems. So like I said, for gasoline, the whole powertrain optimization needs to be looked at together as a whole unit to try and find the opportunities and benefits for your particular application. Then from the after treatment specific side, you're looking at increasing catalyst volume as well, with the potential for ammonia slip catalyst, but this is really application dependent in our view. Then, because of the reduction in particle size measurements for your particulate number, the increasing filtration efficiency, GPFs as well, will be required. And then again, for your cold start emissions light off, after treatment preheating is going to be a requirement as well in our view, especially on using electrically heated catalysts for 48 volt platforms or above. And then we do see there's the possibility of some burner systems may be required on sort of niche 12 volt platforms. Then if you look at the diesel applications, again, quite similar. There's the viewpoint that does need to investigate the whole powertrain optimization, but then from the after treatment side, looking at close coupling your DOC and DNOx devices closer to the engine out condition, the requirement for dual SCR systems really to drop the NOx emissions down. And then also we do see that requirement for after treatment preheating as well, with sort of electrically heated catalysts, for example. But to sort of reiterate the points, the design, the development, the optimization, the validation of these new hardware systems against and across the entire Euro 7 boundary conditions will be a significant challenge to achieve in the timescale that we have available to us. So moving on to the heavy duty requirements now. So what I've presented here is the change in the emissions limits, again, from where we will be with Euro 6e over to where we're going with Euro 7. So it really is a significant step change from where we are currently for the heavy duty sector. But the requirements do follow the proposals developed within the CLOVE consortium. One point for us to note is around the N2O emissions. We believe will be quite a significant challenge, especially on the light commercial vehicle side. With the heavy duty vehicle application, again using the emissions budget approach to enable those shorter RDE cycle distances as well. Then this is the budget is based on a WHCT work percentage for the heavy duty applications. But again, once you go past that 300% WHCT work, you then take across your normal sort of 90th percentile emissions requirements. Again, this is an example for NOx, but then you can use the same procedure for all other applications as well, all other emissions as well. So then moving over to your RDE limits for heavy duty vehicles. Again, it's following the proposals within CLOVE quite closely. I think the most interesting point to note is around the emissions being divided by 2 when any of your extended conditions are met, rather than the 1.6 that we find in light duty vehicles as well. So it's interesting why is there that difference between the 2 applications. I think one key point to note as well is around the gap between the weight classes of different vehicles as well. So you have an M1 based heavy duty vehicle that's above 3.5 tons. There is an allowance now in the regulation. So if it's an N1 style vehicle, that can be certified to light duty regulation up to 4 tons against the Euro6e EXT type designation for type approval. So that's a good benefit there. And then the other aspect that needs to be made aware is around the durability requirements as well. So actually the conformity factor for the durability extension is still to be confirmed by the European Commission. So, is there going to be any additional emissions budget allowed from the 700,000 kilometres up to the 875,000 kilometres, for example, for an M3 over 16 tonnes or an M3 vehicle over 7.5 tonnes, for example? That will come in the delegating acts, but at the moment that information is not available to the OEMs from the European Commission. So moving on to some technology requirements, for example, with for the heavy duty diesel after treatment system. So much like the gasoline, we view this as a whole system optimization requirement. So that's optimizing your thermal management systems, advanced heating systems, and also looking at different sort of combustion opportunities as well. So looking at possibly Miller cycle and cylinder deactivation technologies as well. And then alongside with sort of cooled EGR systems too. Then looking at the after treatment systems, moving much more close coupled to improve your cold start performance for your DOCs and DNOx systems, moving towards more dual SCR systems as well, and then vanadium SCR technologies as well to look at your N2O emissions requirements as well, are possible to come on stream. And I think the other point as well is looking at there may be a requirement for after treatment preheating with electrically heated catalysts as well, where we see this may be a bit of a split across the heavy duty industry. Some applications may require it, other applications may not. It's going to be interesting to see how the different OEMs manage the challenge of Euro 7 moving forward. Again, like the light duty applications, this is going to be a significant challenge to develop these systems, optimize and validate against all of the heavy duty Euro 7 boundary conditions in the time that's available to us. So that's everything now from an emissions and RDE standpoint for Euro 7. So what I'm now going to talk about is around the additional requirements that Euro 7 is bringing on top of the standard RDE and emissions requirements. So first of all, evaporative emissions. I've just got the light duty M1 and N1 application examples here. So you're looking at the changes to the shed testing for the hot soak and also the addition of refueling emissions as well. The potential is for OEMs with federal market vehicles. There is the opportunity there to take some of the technology back across to the European market to meet these requirements. Looking at brake emissions. So this is something that's been carried across from the work that's been done in the UNECE with the PMP working group to develop the brake testing procedure. So we've got the emissions limits that the European Union wants us to work to for these. So until the end of 2034, 7 milligrams per kilometre, but from 2035 onwards, it's going to drop to 3 milligrams per kilometre for brake emissions. I think one interesting point to note is actually the method for assessing regenerative braking and how the emissions reduction from regenerative braking has not yet been defined. So how does different OEMs with different regenerative strategies, how is that applied to the brake testing procedure? That's still something to be defined, but a very important point that needs to be covered in the delegating acts in our view for the Euro 7 requirements. The one that was the most surprising for me personally was around tyre emissions, really. So like brake emissions, all powertrain types need to meet these tyre emission requirements. Why it was so interesting for me that it was added is that the methodology for testing is still in development. They're still looking at either testing it on the road, looking at the durability requirement on the road, or in the lab for these emissions. And there isn't going to be a report available from the European Commission until 2024. So again, really short amount of time between report being delivered and then when the legislation's in place. The really interesting thing about these is actually the emissions measurement is going to be based on a mass reduction from the tyres in grams per 1,000 kilometres, as you can see here from the table. So that's quite an interesting point. And then because these emissions are being viewed as being supplied by Tier 1, so the brakes and tyres, any replacement hardware for brakes and tyres will have to be Euro 7 certified as well. So you'll have to fit, if you have a replacement tyre, you need to fit a Euro 7 certified tyre to your Euro 7 vehicle, for example. Moving on, then Euro 7 is now bringing in battery durability requirements as well. So this is then carrying across the proposal defined by the UNECE working group, so what's in the GTR 22. So our view is these limits have been known for a while now, so OEMs should already be specifying their battery hardware to meet these requirements. One interesting point that has been added on top of the GTR 22 requirements is the battery durability to an additional lifetime as well. So we believe this will be from going up to 10 years or 200,000 kilometers for battery electric vehicles and PHEVs as well. But the actual minimum performance requirement is still to be specified, and this will be specified in the delegated acts of Euro 7. Then another interesting thing for battery durability is the requirement for N1 vehicles as well. So the durability or the minimum performance requirement hasn't been set within the GTR 22 regulation yet because of the very disparate different driving styles that could happen could be undertaken by N1 vehicles. That information hasn't been set, but now we have limits defined for Euro 7 from the regulation of Euro 7 released in November. So which is very, very interesting to see. And then for heavier duty vehicles, so the M2, M3 vehicles, N2, N3 vehicles, these limits have yet to be defined and will be defined in the Euro 7 delegating acts. Now, moving on then to onboard monitoring. So we believe at Mahle Powertrain that onboard monitoring is going to be the most significant challenge of Euro 7 that we see. I think the key point to make around OBM is that actually there's no technical or detailed technical information has been provided up to now within the Euro 7 proposal. You know, from our view, OEMs really require detailed sensor specifications, the operating requirements of these sensors to enable us to understand when will sort of backup modeled emissions models be required. Then what are the requirements for valid OBM trip requirements? So when would you need to report an emissions measurement for a particular drive cycle? Is there a minimum distance, for example? And then it's also about the data analytics as well. So what averaging is going to need to be done? What are the emissions tolerances on these sensors? And then what tolerances will be given against the emissions limits provided within Euro 7 as well? So that's really key questions that information that we still need as OEMs and Tier 1s and we don't currently have. So as I said, there's been some really good information, but it's still limited to the technical detail. So for example, here we've got examples provided by Chloe of how the OBM will operate in conjunction with the onboard diagnostics of the vehicle as well. And then they've also provided examples of how the onboard monitoring emissions calculation will be performed as well with different individual trip values, and then a running average through those. And then once the emissions limits go above the the emissions go above the limits, the average emissions go above the limits, then what are the then inducements that happen to the vehicle? And if there's then no repair, what the restriction applied to the vehicle, what's that restriction going to be, for example, and how much time does an owner have until the vehicle is going to be, not allowed to start. But one of the really interesting things that was presented in the latest AGVES meeting was around an onboard monitoring sensor survey that was performed by the JRC. I've got the details of the presentation here and the report that's out of there. It's a really interesting read for anyone who's interested in onboard monitoring. But basically they went through and tested a Euro6e application which had NOx sensors installed for the diesel after treatment system, and reviewed the data, how that compared to lab and PEMS testing as well. And you can see here the error margins that they saw from that data. I think there's just one key point to mention. As you can see here, the warm-up times were very long, and if you had a NOx sensor engine out, the warm-up time was over 300 seconds at 23 degrees. But then also the data presented, especially in the lab testing, was from warm start data as well for the onboard monitoring. So there's still definite gaps to be closed on the data collection and understanding to be able to pull together a really detailed understanding of what areas are we looking at, how these sensors will perform in the real world when running against onboard monitoring data. But yeah, like I said, this report is a really good start in understanding what the European Commission is thinking and what are they looking at to understand what's going to be delivered as part of the onboard monitoring requirements for Euro 7. So really, as I said, the onboard monitoring is going to be the most significant challenge for Euro 7, and we believe that OEMs and Tier 1s need to answer sort of the following questions, which are around, well, how can we validate the onboard monitoring emissions measurements across all the use cases and durability requirements that we're seeing in Euro 7? How are these emissions models that will be running in the background if the sensors aren't operational? How are they going to be implemented? How, are they going to be required for cold start operations? Again, a bit of a question for the European Commission as well. But then how accurate do they need to be, and how can we get that accuracy measured as well? And then I guess one of the really other interesting points is how can you actually pinpoint the cause of an emissions exceedance measured from onboard monitoring? Because if you've got multiple components which are aging at the same time, if the vehicle comes into a dealer with an onboard monitoring exceedance, which component is going to be fixed? Is the whole after treatment going to have to be replaced for the customer? That becomes a significant cost, and possibly a very unhappy customer of the vehicle as well. So these are very difficult challenges to achieve for OEMs. What I wanted to sort of briefly talk about is what we're doing at Mahle Powertrain to try and answer these questions as well. So we've had lots of experience in generation of emissions models. So this is performing sort of virtual calibration optimization techniques. So using advanced DOE data collection to build up very detailed emissions models, and then performing virtual optimization on these models as well, to then understand exactly, to get very accurate emissions models compared to measured data. So you see an example here from the capability at Mahle Powertrain for virtual modeling of emissions. We've got PN, HC, CO, and NOx. For example, the gaseous emissions, blue is post-cat, black is pre-catalyst emissions as well. So you can see both we're able to model the implication of the catalyst well, and again with PM we're able to get very good correlation between measured and modelled, and also the models are capable of seeing differences in calibration as well. So these are just some of the techniques that we see are going to be required moving forward into the future to achieve the challenge of Euro 7. I think this has been a theme throughout this presentation really. At the moment, we feel there's insufficient detail to be able to meet the OBM challenge. This is something that the industry Tier 1s need a lot of information very quickly for the European Commission to be able to design solutions to meet the challenge of onboard monitoring. And for light duty application, as I said at the start, there's only 42 months to go to find the solution for this. So really, this has come to the final part of the presentation. So I just wanted to summarise really what we discussed today. And really, I believe that the journey to Euro 7 is only just beginning. There's still a considerable amount of work required to deliver light-duty vehicle, heavy-duty vehicle applications to the challenge of Euro 7. Overall, we believe there's significantly more information required. The European Commission itself knows that it has to define technical implementing acts for all 23 phases of Euro 7 type approval, and we don't believe that's going to be ready until Q1 2024. So that really does compress the timeline that we have for a fixed regulation. And then with that timeline, there are significant challenges to overcome, like I've mentioned, with onboard monitoring, and then also being able to just validate the hardware to meet the compliance requirements for all Euro 7 boundary conditions. And then also the challenge of actually certifying all these light duty and heavy duty vehicle applications as well within the timescale for Euro 7, which all vehicles have to comply by Euro 7 for light duty by July 2025 and heavy duty by July 2027. So that's going to be a significant challenge of just to get these vehicles certified as well. But on an interesting side note as well, there were some unexpected inclusions in Euro 7, where the European Parliament have requested the European Commission to actually develop a framework for light-duty vehicles running on CO2 neutral fuels as well past 2035. So this one for us at Mahle Powertrain was quite an interesting inclusion, and we'll be following this quite closely to see what that means and what types of fuel would be covered by the CO2 neutral requirements as well. So it's something very interesting to follow, and seeing a bit of a technology diversification for CO2 neutral transport moving forward towards 2035, which is really good to see. So that today now concludes my presentation. Almost managed to get it under 30 minutes. So now we've got some time for questions, and hopefully Steve would have sorted out some results of the survey as well. So just like to thank you all for listening, and yeah, really looking forward to answering some of your questions.
Okay, thank you, Simon. Okay, so we have got the results of the poll. Can you see them, Simon, on your screen?
Not yet. I'll just stop. No, I can't see anything, Steve, unfortunately.
Okay, all right. Well, I can. so that's handy. Okay, so we'll just run through the poll results, and obviously you can add your comments. So the first question: what is your opinion on the implementation timing of light duty vehicle Euro 7? So we've got. I'm not sure if the audience can see this as well. Hopefully they can. But we've got 34.3% saying it's too early, 25.4% saying it's too late, and 40.3% saying it's just right. So bit of a equal split, roughly speaking. No clear answer. And again, I don't know the demographic of the audience, but it seems most are saying it's just right.
Yeah, no, that's quite interesting. It sort of compares to what the response we've seen in the press, really, about how it was quite a mixed bag of opinion of it. So that's really interesting to hear.
Okay.
Yeah, maybe you could can you publish results to the audience if you press that button? I don't know if that's.
Oh yeah, there we go. Hopefully the audience can see it now. Let me just quickly run through and do the others. Okay. Okay. So, well, hopefully people can see. So the next question then. So, what is your opinion on the pollutant and RDE limits of light duty vehicle Euro 7? So is it too lenient, too aggressive, or just right? So 25.9% say it's too lenient. 7 to 12% say it's too aggressive. I don't know why it says 7 to 12% there, but it looks like 12.1% say it's too aggressive, and 62.1% say it's just right. So, so they're kind of harmonising of all the worst bits of Euro 6 seem to be a sensible option in our view. And again, it will be interesting to look at the demographic of the audience to see where this view has come from. Obviously, it depends whether you're what side of the fence you're on, whether you're an OEM or a tier one or a consultancy or whatever, or an NGO. But so okay. The third question, again, so we're into heavy-duty vehicles. So what was your opinion on the implementation timing of heavy-duty Euro 7? And basically, well, unsurprisingly, it's pretty much the same as the light-duty vehicle. So again, we got an even split. It's slightly more even here. In fact, if you were a statistician, you'd probably say it was down the line. So we've got 32.7 saying it's too early, 29.1 saying it's too late, and 38.2 saying it's just right. So again, we have an even split. Okay, and again, for the heavy duty Euro 7 pollutant and pollutant and RDE limits, again, this reflects the same as the light duty. We've got pretty much 50-50 on the too lenient and too aggressive. So 28.8% on too lenient, 23% on too aggressive, 48.1% on just right. So again, I think the conclusion from the audience, the numbers are about there.
Yeah. No, it's interesting. I think then the final question I think was quite an interesting one, which I'd like to hear if there's any on that one.
Yeah, so this is very interesting. Do you think Euro 7 will reduce the number of LDV ICEs applications available in the EU market? We have a pretty clear answer to this. 93% yes.
Oh, yeah.
No. So the EU Commission have stated many times Euro 7 is not a mechanism to discourage ICEs, but clearly the view of the audience is that it is.
Yeah, and I think for me that really comes down to the difficulty in actually getting the vehicles ready in time to meet that deadline. I think that's for me that's what it's going to come down to essentially. So getting them type approved, getting them on the market, getting them robust and ready.
Yeah, spending the cash to do this, with all the other pressures of full electrification. And is it a distraction? Is it just a big distraction from electrification?
Yeah, that's a really good point.
Good. Okay. Well, we'll move forward into the questions. We have a number of questions. I must admit, it's not the tsunami of questions that I was expecting, but there are enough questions to keep us going without me having to ask you a really horrible one. So that's pretty good going. So we've got a question with regards to the power mass ratio targeting underpowered heavy N1 vehicles, which is less than 35 kilowatts per ton. Is the mass used for this ratio calculation gross vehicle weight? So that's pretty straightforward. Detailed question, whether you know it off the top of your head.
No, unfortunately, I've got a limited amount of memory that I can keep lots of EU7 details in. But what I can do, I can go back to my notes and answer that question offline. So we've got your email address there, so I can answer that later on today.
Okay,
so that's not a problem.
So the next one is: do you think? And I think this is quite an interesting one. do you think OEMs could apply a cold power limit through software to meet gasoline LDV emission limits as an alternative to investment into such as heating? The main challenge seems to be cold emissions during catalyst warm-up. Therefore, limiting ICE power could be one approach. Well, or maybe not limiting it. I mean, it's warming the thing up is clearly the key. But there's that also. Can I just add to that the limit on the first 2 kilometres? Maybe you want to make a comment about the power, because there's the 20% power limit on the first 2 kilometres. How on earth is that going to be measured and limited? So I think it's in the same.
Yeah, so it's it's an interesting approach. So it's basically the regulation for the first 2 kilometres is going to, after the test, is going to look at the first 2 kilometres after an ICE starts to then have a measurement of your wheel power, and that will then define whether if it's below 20% of your maximum possible wheel power, then that'll be in the normal conditions. If it's above 20%, that'll be in your extended conditions, emissions allowance condition. But still, that's still then within your cold start requirements. So it'd be 1.6 times the base emissions, for example, for NOx of 600 milligrams total for a
so your control system will have to. You obviously can't measure wheel torque in the vehicle unless you use strain gauges on drive shafts, which you can't do on a production vehicle. But so there's going to have to be some model-based approach in the EMS to do that.
Yeah.
And to the gentleman's question, it's like, so would you see a need for some kind of intelligent energy management in the warm-up through the ECU to maybe limit the power?
I think there's opportunities at the moment, so to apply torque limitations on your sort of engine clutch torque outputs, and then there is then you can do a calculation from your engine clutch torque through your gearbox, through your drive shaft to your wheel. That's a calculation that is feasible within the software. But if we just go back to the clutch torque point, there are opportunities where you can limit your clutch torque. So you could have a cold start in the car, say it's a 5-degree cold start, and you could have a light on the dash to say torque limited operation of the engine, so the driver does know that there's not going to be the full amount of torque that's available. But even so, if you do, I think that it's a really good question. But even so, even if you do have a torque limit, so if you've got like for example, a 400 Newton meter engine and you limit the torque by 50%, you've still got 200 Newton meters. You can't really limit it much further than that. Otherwise, the car, when the delta in acceleration between full power and limited power would be quite high, so that could become a safety concept issue. But then still, you'd then be able to drive at 200 Newton meters, for example, in that cold start region. So it comes down to how the OEM wants to approach it. So if you do want to have a torque reduction that is feasible, that's able to do now. But then it's how much power would you want and how much load to apply to a system with a cold after treatment.
Okay.
Because even if you've got a cold after treatment system, there's just no catalytic efficiency for the first 5 to 10 seconds.
Exactly. Yeah.
It does build up. So even if you can have maybe a combination of the two, so a less aggressive heat, less powerful e-catalyst, for example, plus a torque limitation, could then make your after treatment system a bit more cost effective, for example. Yeah,
well, I think probably the answer is if you have the levers in the control system, then they'll be used. So I think everything's up. But this also leads into, it's a good segue into the next question, because clearly you're having, if the vehicle is a PHEV, you have more levers and you can manage that ICE operation, initial ICE operation with a combination of electric propulsion and ICE. So the next question is, so PHEVs were seen as a bridging technology and a compromise for cost and performance. Does the detail of the EU7 encourage currently pure ECVs, ICE currently pure ICE vehicles to adopt PHEV. So really, is the PHEV version easier to comply with Euro 7 versus pure ICE? What's your view on that?
It's a really interesting question. There's lots of factors around the PHEV discussion at the moment because of the implication of Euro6e and the CO2 requirements as well, because the CO2 fleet average benefit of of PHEVs is going to be reducing quite significantly over the next 5 years as well. So that then brings another decision to the manufacturers of whether they want to include PHEVs in their vehicle fleets for the European markets, because PHEVs are, in my opinion, quite a nice balance, because you don't have such a large battery capacity, and actually they do cover quite a lot of the day-to-day driving, especially some of the longer range PHEVs that we're seeing come to market at the moment with 25-30 kilowatt-hour batteries. That will cover most people's use cases, daily commutes much better. But yeah, then looking at the gaseous and particulate emissions, you do have additional levers to pull for a PHEV application, especially when you can do like a load limited cold start on the ICE engine as well. So if you see that your battery is starting to get quite depleted, or if you're using some sort of event horizon type technology, and you see that the engine's just about to go onto a vehicle, is going to go onto a motorway, then potentially you could warm the catalyst up, do a very gentle cold start on the engine to then bring the after treatment up to temperature before you've actually reached the point where you're going to perform a highly dynamic maneuver that could cause emissions. So using your electrification opportunities within a PHEV is a very good option to enable Euro 7 emissions compliance.
Okay, great. We're approaching the end of the hour, but I will try and squeeze another couple of questions in. So on the subject of systems, because that was where we were leading. So what impact do you think the additional after treatment systems will have on the cost of the whole systems and the vehicles for both light duty and heavy duty vehicles? So
that's something I can't really comment on. It's a little bit difficult to answer. There's a lot of work done on this by the European Commission, thinking the documentation on the regulation. So the impact assessment had lots of details on cost addition for Euro 7 applications. That was material cost. There was discussions around for each ICE application. It was $200, $400, $600, I think, per vehicle, which will after the system cost be. But then, in my view, that has actually missed the additional costs of development, the utilisation of a significant chunk of the R&D engineers and development engineers, collaboration engineers' time to develop these Euro 7 packages, when actually Steve is the better be spent that time actually on electrification programs as well. So it's quite interesting that the impact assessment pure the cost of hardware and the cost of developing these new systems. Yeah, the heavy I don't know, unfortunately I don't have data off my head.
Okay, well, thank you for that. I think we're coming up to the end of the hour now, so we do have a few more questions. But as we said, so you've given out your contact details in the webinar, which will be made available as the video of the webinar will be published, and the IMechE will provide that information to all the audience. I can roughly answer the last question we had was how many people there in the audience. We think we've got about 300 people in the audience, so quite good attendance. Okay, so Euro 7 obviously is not pleasing everybody. In fact, I mean, it's pretty much not pleasing anybody, but I suppose you could argue that it might be just right. If the environmentalists aren't happy and the OEMs aren't happy, then it could be in the happy ground in the middle. But obviously, it's going to be a challenge for everybody, and the implementation dates is a huge challenge to get new vehicles in production. So, okay, I'd like to end it there. Thank the audience for their attendance, and please stay in touch and keep an eye out for future IMechE events such as this. We aim to keep you informed and to gauge your opinion and feed that back to the powers that be. So thanks very much, and yeah, goodbye. Have a good day. Thank you.